this is the last video, and it talks about the practicalities of privacy and confidentiality. You've got a sense of the context, why it's important, the framework, the risk utility framework within which we operate. And now we're going to talk about disclosure control. So practically, what do we do about it? So as we've said before, the aim of disclosure control is practically to say no unauthorized individual, technically competent with public data and private information, could figure out something about you that wasn't already public knowledge and associate that information with the supplier of that information. In other words, say, I only know this because the data steward, for example, a state or a federal agency, made those data available. So that's the aim of disclosure control, to ensure that that doesn't happen. There are three different ways in which disclosure can occur. And the Stats Canada has a very nice write-up of this. One is identity disclosure, in other words, that you figure out that Julia Lane did something. The second is attribute disclosure, where you figure out that something about my earnings or about my behavior based on a particular set of attributes that I have. So the example that I always use is, suppose that the data that are released by the federal government show that all New Zealanders are axe murderers. Well, then you've found out something about me because you know I'm a New Zealander. You know from the federal government that all New Zealanders are axe murderers, therefore that's attribute. And then we're going to spend a bit of time today talking about residual disclosure. That's a little bit harder to understand, so I'm going to spend a little bit of time on that. So the historical approach to protecting, so I'm going to illustrate through practical examples. So the historical approach has been to try and reduce the number of individuals, reduce re-identification by increasing the number of individuals in a cell. To be very specific on that, the limiting value, for example, is you should never have fewer than 3 people in a cell, because if you show something about an individual and there are 2 people in a cell and I'm one of them, then I immediately know something about the other person. With 3, there's some degree of differentiation. So the minimum number in a cell should be 3. Usually agencies will say at least 10 or at least 20. It depends on the agency. These are very ad hoc approaches, and so quite often what agencies will do in order to reduce the likelihood of re-identification, they'll either aggregate age categories, for example. So instead of looking at age 5 to 10, they might increase the age range from 5 to 20 for the cell. They might simply suppress a cell. People will use that a lot, just blank out the information that's in a cell. They'll swap, they'll change thresholds, they'll add noise to the data. All of those are different ways in which information is protected. There's been a massive amount of research, because the cell suppression in particular is biased, in the sense that if you're dealing with data for a small county or a big industry in a small county, lots of information gets suppressed. And that's biased, because then you're only getting information about big counties and small industries in big counties. So there's been a big focus on something called differential privacy, which offers a privacy guarantee and says what we're going to do is we're going to add noise into each individual response, increase the noise, and then you can't figure out whether or not that individual is in the cell or not. And that's in many ways preferable, because it preserves the statistical properties of the data. The challenge, and it's been very much embraced, I think, by the computer science and cryptographic community from which it came. but there have been tremendous pushback on it by the social science community for a wide variety of reasons, and you can particularly look at the work of Steve Ruggles for what the challenges are associated with that. These are a set of videos that I think will summarize the information for you. It's certainly beyond the scope of this video to talk through the issues that are associated with choosing between self-suppression and differential privacy, just to make you aware that that is an ongoing conversation. Obviously, what we have chosen to do with the ADRF and with the providing secure environment is to take the approach of reducing risk from a practical point of view by simply creating a secure environment. And we go by the 5 safes. It has to be for a safe project. So all of you work in the ADRF, it's an approved project. You are all approved people. You are working in a secure environment, which is the FedRAMP secure environment. The data on which you're working has been de-identified. Notice, not anonymized. And then the last step is that the data, before it is released, it has to be aggregated and disclosure reviewed before it goes out into the public. And typically what we're talking about is tables or regression results or statistical results. So I'm going to talk through the practicalities of that to understand what happens. So typically when there's disclosure, we're going to use the old-fashioned approach. When we're worried about protecting disclosure from primary tables, we typically use the threshold rules. Most agencies require that we apply the rule that no cells with under 10 units of individuals or enterprises is released. So for example, when you take a look at a table like this, when there's this number of firms, you wouldn't release the cell with 8 or the cell with 6. So you'd suppress those 2 cells. That occurs even when you're dealing with percentages. Obviously, in this particular case, when you're looking at the breakdown of hourly earnings by occupation, there's 949 total count of nurses. So 1%, that's 9.5. So we would suppress this cell. There's an attribute disclosure here at 0% because it's saying no nurse makes more than $10 an hour. So if I release that cell, if I release that information, that would be telling me that no nurse made more than $10 an hour. So that would be an attribute disclosure. If you're dealing with frequencies, you can see here that you can figure out when you're dealing with a graph, you have to provide information about the frequencies of the individuals. What do we mean by secondary disclosure? What we mean here is that you can figure out when 2 tables are presented that you can infer something about a table, about a company, by just doing a difference between the 2 tables that have been released. So for example, I were to release this table about US-based companies and this table about all companies, you could figure out by differencing industry 102 that you have 1 company that has sales of 145. So you can see that secondary disclosure or complementary disclosure can be very difficult to determine, and clearly the more tables that you release, the greater the likelihood of secondary disclosure. And in a very famous example, and one of the reasons the Census Bureau is rightly concerned about the 2020 census, is that they calculated that for the 2010 decennial, they had released over 5 billion cells, and you were able to identify the characteristics of 50% of the population as a result of the release of 5 billion tables. Now, of course, you know, back to the issue of risk versus harm, there's not a whole lot of very useful information in the decennial census other than your age and your sex and so on. But it was still disclosure, and that is illegal for the decennial census. Let me give you a couple more examples. What about this one? How can you figure out whether there is complementary suppression here? All of these cells look okay. There's enough people in each cell. Well, it turns out that because you've got north, south, east, west is not there, but all is there. So you can figure out by differencing that there's a company in the west in industry 102 which has sales of 1,200. You can see this is difficult stuff to figure out. So what about a table like this? Well, if you take a look at full-time jobs and all job types, you can see that there's a difference here in dentists. So you could figure out that part-time dentist has earnings of $9.50. Okay, so there's all kinds of challenges associated with doing these differences. So in general, what are the practical implications for you? Be careful when you're tabulating raw data. You think about the threshold that is required. You've got to be careful about using measures like investment, because quite often there can be just a couple of companies that have investment and the rest of them have zero. And so you can run into problems there. You can worry about when you're dealing with small geographic areas, because then there might be just one company that has 80% of the sales in that company. So for example, in that area, if I were to talk about an aerospace company in Seattle, it's going to be pretty obvious what that company is. So combining both industry and detailed geography can really get you in trouble. Graphs are tables in another form, so you should always display frequencies, and really minimize the output request, not only because it's time consuming for our staff to review it, but also every release compromises the next release. And so you simply cannot get by with releasing this information. When you're requesting output, provide us with unweighted frequency counts. Do some review yourself on small cell sizes. Try and make your crosstabs just 2 dimensions, at the most 3 dimensions, because it's very hard to figure out the differences. Don't submit big listings of cases. It should be small tables, small information, and of course, check the documentation for agency-specific rules, because different agencies have different rules, and we'll apply those rules. There's lots of good videos and readings to take a look at. This is a fascinating field, and I hope you enjoy taking a look at it and answer the questions for this section of the website. Thanks.